This is our STM32 Nucleo H753ZI board, and there we have the USB to TTL device. You can see that this is blinking. It means some data is being sent. Okay, let's go to the serial monitor to see what is being sent. So we are getting hello world. So STM32 is sending the hello world over the serial monitor with a baud rate of 115200. So if I show you the hardware, there we have connected our STM32 PA0 and PA1. Two pins are being used. PA0 goes to RX, PA1 goes to TX. PA0 is a UART4 TX and PA1 is UART4 RX and ground is ground. So if I go to my CubeIDE and I show you the hardware side, see PA0 we have declared it as UART4 TX, PA1 as UART4 as RX, and here you can see that we are using UART. We enabled the UART4 port and then we set it to asynchronous mode. After that we set our required baud rate and whatever settings 115200, and if I go to the C code, you can see that what we did is that we wrote a simple 3-line code. See, we first of all declared a char, an array of char which is a string, and in that we wrote our message hello world, and then this is the command to send a string or send any data over the UART port. Now you change the, over here you will only change this part. The port we are using is UART4, and the message will be sent as it is, and message is written here, that is hello world. Then length of the message, it is str length, and then the delay, and delay we are giving is manually. This is a 1 second delay after every transmission, and this programming and this hardware is giving us this result over here. We are getting hello world on the serial monitor over the UART4 port, and after every 1 second we get one hello world. Guys, welcome to learning microcontrollers. In this video I will show you how you can interface a Nucleo STM32H753ZI based board with a USB to TTL device, and we will be using this USB to TTL device as our external serial monitor. Like, we will sending the data to our computer using this device over the UART port. So for the USB to TTL device, you can use any USB to TTL device like FT232, CH340, CP2012, or whichever one is available at your place. And the programming IDE that we are going to use is STM32CubeIDE. So guys, this over here is our STM32 Nucleo H753ZI board. It's the bottom side. And guys, this over here is the USB to TTL device. This one is the FT232. You may use other as well like CH340 and whichever one is available. Now guys, let's do the connections. So guys, before we do the connections, let me label this device for you. The top pin is a 5 volt, then VCC 3.3 volt, TX, RX and ground. So guys, as you can see, these 3 pins TX, RX and ground, they are common in all the 3 USB to TTL devices, while these 3 pins 3.3 volt, VCC and 5 volt may vary. For our application like this, where we are using this as a serial monitor, like we will be sending strings or text, whatever, like we just want a serial monitor just like an Arduino. But here, unlike Arduino, we will be using this device to send the data to our serial terminal over the computer. So for that, only 3 pins are required, TX, RX and ground. We do not need to power up this device through the microcontroller, because once you insert the USB into the computer will automatically power up this device. And you may use this power to power up your microcontroller if you don't want to power it up from the USB port. That's up to you. So guys, let's do the connections. Now to do the connections, you need to select a UART port. Our microcontroller have over 9 UART dedicated hardware ports. So I'm going to use a UART4, and the UART4 is like assigned to 6 pins, 3 TX and 3 RX. You may use any pair like PC10 and 11, this is one pair, PA0 and PA1 is one pair. So we will use PA0 and PA1. So PA0 and PA1. PA1 is the UART4 RX pin. I will connect it to the TX of my USB to TTL device, because for the UART communication to succeed, TX goes to RX and RX goes to TX. And for the PA0, I connected to the RX of my USB to TTL device. Now, as I told you earlier, TX to RX and RX to TX. PA0 is the TX pin of UART4 on this microcontroller, and PA1 is the RX pin of the UART4 port. We will declare them on our GUI. Other than this, you also have 3 TX and 3 RX for the UART4 port. Those pins are, you can just check them in the data sheet. I'm going to use these two. So now for the ground, you need to connect the ground, connect it to any ground pin of your STM32. There are a lot of options. You have ground here, you have ground here. Whichever you use, all are same. So just connect it to any available ground pin. So in this way, our connections are completed. Now let me show you the hardware, then we move on to the programming. Guys, this is our hardware. As you can see, this is my USB to TTL device. As you can see, this is our STM32 microcontroller, and this I have connected to the computer. Also, the device has also been connected to the computer. Wiring is as shown in the presentation, so no need to worry. So let's move on to the STM32CubeIDE to start the programming. So I click on STM32CubeIDE, let it start. So here we go, it started up. Let me use the magnifier to zoom in. So first of all, you select the workspace. This is the main folder, and the project file that we are going to create will store in this main folder as subfolders. So I click on launch. I have no problem with this name. Okay, you have to wait. As I told you in my first video on STM32CubeIDE, how to download and install it, that's available in the introductory section. So you can go through that lecture and understand how to download and install and use this tool. Remember that whenever you are using this tool, it is free, but you must be logged in, else some features like updates will not be available. To log in, you have to go to help. Here in the MyST, you have this update. There you connection to MyST. You must be logged in. It's free, no money is required, but you have to log in. Now click on file, click on new, STM32 project. Wait for the window to appear. It takes time, so you have to wait. It may update as well, depending upon how often you use it. If you use it after a long time, then many updates might be pending. So you have to select the board. Either you can go with the board selection or with the microcontroller selection. In case your board is, if it's not available in the list, then you select the microcontroller. That is the black chip on the Nucleo board. So I will go to the board selector, and the official name of my board is H753ZI. So this is the one. Okay, this is the one. To verify this, this is the correct one. I can go through these description. Okay, it was this price, $27. Yes, supports Arduino, 144 pin Nucleo board. Okay, that's perfect. Click on next. Write the name. Now this will be the subfolder. I call it UART tutorial. Okay, click on finish. Okay, you have to wait. I think the loading is done. Okay, click on OK. Now he's asking for the onboard component. If you want to use it, you may use it. I click on OK. We will be using external, we will be making external serial monitor. Unlike Arduino, where the monitor is built in, we are connecting the USB to TTL device externally. So it will be just like a serial monitor, but an external one. Okay, wait. It is generating the GUI. It takes like 25 to 30 seconds, depending upon the pending updates and also upon the speed of your computer. So you have to be patient. You can see that it is downloading some stuff and doing a lot of stuff over here. Okay, here we go. It's generated. Okay, there is the microcontroller. Look for the PA0 and PA1 because we are going to need the UART4 port. Now there you have the PA0. Now left click on the PA0 pin. Okay, I zoom in here. Okay, once you left click on the PA0 pin, this menu opens up. Look for the UART4TX. This. Click on it. Now this has been declared at UART4TX. And for the PA1, click on it. There you have the UART4RX. Click on it. Now PA0 has been declared as UART4TX because on this pin, our USB to TTL device is connected as RX, and here it is connected as TX. So our USB to TTL device is connected on these two pins. Now go to the left side. Here you go to connectivity. There you have the UART ports. This is the port we are going to initialize, UART4. Now instead of disable, make it asynchronous and set your desired parameters like whatever the baud rate. Okay, 115200, not a problem. So we will be going with this baud rate. Okay, it's fine. Okay, once you are done, click on project, generate code. Okay, click on yes. Now you have to wait for the code to be generated. There you go, the code has been generated. Now a lot of things have been done already. All we need is a HAL UART4 command. So now to get that command, what we have to do is that we will take the help from the AI. Instead of going through the documentation to search for the command, we just directly go to the AI. So I will open my Chrome or whichever browser you have. I click on Google. I write here ChatGPT. You go to ChatGPT to ask for help. Okay, now this is important. You need to learn to write how to write the prompt. Writing the prompt is the only thing you have to do in this era. So I say I have Nucleo STM32H753ZI board. I am using STM32CubeIDE. I have connected a USB to TTL device FT232 at pin PA0, and PA0 is our TX. You can verify it. You can verify it either on the presentation or on the GUI. PA0 goes to RX, so PA0 is a TX. PA0 is a TX, and PA1 as RX of the UART4 port. I want you to generate me a code so I can send hello world to my PC. W should be capital. Hello world to my PC over UART4 using USB to TTL device. Okay, and we also need some delay, else the code will be too fast. Also give delay of 1000 millisecond after every transmission. Okay, press enter. Now wait. Okay, PA0 as TX, RX, baud rate is 115200, no issue. Okay, now see, a lot of code has been generated, but remember that our GUI has generated all this code. We only need the commands in the while one, these two commands only. Now these are the command. Okay, this message command, like it is making a message, and then these two commands. Okay, first I copy these two commands. You copy them, go back to your STM32CubeIDE. In the while one loop, you paste them over here like this. Now go back. Also you need that command in which you are loading the string variable. Okay, it can be either in the one-time loop or it can be in the forever loop, this command. I copy this as well. Go back. Okay, I pasted in the forever loop. You can paste it in the one-time loop as well because I may change it. Okay, now take a look here. What is happening here? We initialize a variable called message, and message variable holds, it's an array of char. An array of char is a string, hello world. So in case of micro C, we also declared char instead of string. In Arduino, we have a great feature like we have string directly. So in most of the IDEs, an array of char is taken as a string, also in here as well. So the next thing is, where it went? Okay, I think I scrolled up. Okay, there it is. Okay, now the next thing is this command. Now this is the main command. That's what I needed. That's why we went to the AI. HAL UART transmit. This command is used to transmit the data using the HAL library. First of all, this is your syntax. You will write this same. Now which the UART port we are using UART4, and then what text you want to send. You may write text directly here, or you may write it in form of this integer like this, an array of char. The message sent a unsigned integer 8-bit, that is the message, and what message contains. This is the thing only changing here. You just consider it part of the syntax, and message, whatever you write here will be taken as message and will be sent. Now str length, this is just to define the length of your message, and then delay whatever you want to send. So I will give delay over here like the AI has done. I will also do the same to make it simple. So this is the syntax of the command. Only thing that needs to be changed is the port number and the message. Rest will remain the same. So this is it. This is our code. We build this code to see if we have any error. So now to build the code, you go up, project, click on build project. Now go to the bottom, check. It will be doing something. Okay, 2 warnings but 0 error. Warnings may happen like sometimes things are not used or sometimes there is a problem, but there must be no error. So warning is not an issue. Okay, this is it. Now what we do is that we go to run and we click on this green arrow over here to burn it into the microcontroller. Remember, your STM32 must be connected over the USB port. If you don't have this one, you have other STM32 not having the built-in ST-Link. If you are not having the Nucleo board, then you have to connect the ST-Link to your computer, and ST-Link must be connected to the microcontroller. So then click on this button. Once you have connected it, click on OK. It will download the code to your microcontroller. Now you have to wait. It is doing something. Okay, waiting for debugger. Wait for the code to be downloaded. Like it's like just burning it. Okay, it's done. It's burned successfully. Now we first go to the hardware. This is the hardware. Okay, you can see there is a blinking on the serial USB to TTL device. See, after every 1 second it is blinking. It means something is being sent. So we go to the serial monitor to see what is being sent. As per our expectation, it must be the hello world. So you can use any serial monitor. I will use an online serial monitor called fast serial terminal. You can use any serial monitor available. This one. Click on connect. Okay, baud rate is correct, 115200. Remember, that is what we set. Click on connect. If you don't have this, you can use serial terminal any that you have installed. Okay, in my case, what's the problem? Okay, COM6 is the USB to TTL device in my case. Connect COM6. I click on connect. Okay, it is sending hello world. See, this is what we send. After every 1 second, it sends a hello world. Now, whatever text you want to send, you just go to your STM32 and just rewrite the code. The syntax will remain the same. You can use the other ports as well. You can change the baud rate as well. You know how to do that. I have shown you. So this is a very good thing. Like if you are programming a complex project and you need a debugger or you need something what is going in the code. Just like in case of Arduino, we have the serial monitor. So here you can use an external serial monitor like this. So this is of great help. It can also be used to establish communication between multiple STM32s or with different type of microcontrollers like STM2 Arduino, STM2 PIC, or whatever you have. So guys, this is it. I hope you guys learned something from this video. If you have any questions, please do ask. We'll see you in the next lecture. Goodbye until